Hi all, welcome to Coding Talks podcast with myself Vishnu VG. The Coding Talks is a technology podcast which covers a wide range of technology topics from programming to cloud computing. The intention of this podcast is to give the audience a familiarity about different technology topics out there. One of the interesting thing that you can observe in information technology field is that the technologies change at a rapid pace. So that demands a lot of pressure on ourselves as developers as well as those who interested to know about technology. They need to learn constantly. So my intention is to share some of the knowledge that I know. And it doesn't matter whether you are an experienced programmer or not. If you are interested in learning and if you have a curiosity to learn some of the technology topics, the podcast will benefit you a lot. So all are welcome. About myself, I am a .NET programmer from Thiruvananthapuram, Kerala state. Thiruvananthapuram is a beautiful city located on the southernmost part of India. About my programming background, I have experience working with different .NET technologies and front-end technologies, and also experience working with the different cloud platforms like Microsoft Azure, Amazon Web Services, GCP, and so on. I am a community builder for AWS storage. In addition to this podcast, which will be available on all leading podcast platforms, I will be conducting sessions on Meetup group. The name of the Meetup group is Coding Talks Cloud Computing. If you are interested in learning from me, I suggest you to subscribe to that Meetup group as well as my YouTube channel. The YouTube channel name is also same as this podcast, Coding Talks with Vishnu VG. So if you subscribe to that Meetup group and YouTube channel, you will get notifications of the upcoming sessions. So that's all about me and my technical background. Now let's dive into the topic of today's discussion. It's about microservices. Those who were regularly listening this podcast, they know that I have covered a few of the architecture related sessions earlier. And in that I covered some details about microservices, and many of you might be already familiar with what a microservice is all about. But in this episode I would like to present microservices from the ground up to give you some familiarity of what it is all about. Also, if time permits in this episode, we will look at some advanced topics like the implementation, how to implement the microservices for a new applications as well as to migrate existing application, as well as the different development strategies and deployment strategies as well. If time didn't permit me to include that in this episode, that will be a different episode as well. So stay tuned with this podcast. The reason for the relevance of microservice as of now is that I can see those who are interested in application development, whether they are beginner or experienced professionals, they prefer to work in some of the technologies like Docker, Kubernetes, and so on. So these Docker, Kubernetes, these different cloud services like AKS, EKS, Azure Kubernetes Services, Elastic Kubernetes Service, and all on, and the different container registry services. These are all the kind of supporting technologies that are somehow related to microservices. Even the recent trendy word like the serverless concept, where you don't need to bother about the infrastructure at all, and also the function as a services which you can see in different cloud vendors, that are also somehow related to microservices. So these services facilitate or support microservices architecture. In fact, one can say that the buzzwords like the Docker, Kubernetes evolved this much for the effective implementation of microservice architecture. This brings to a question why a developer prefers microservice architecture for developing applications. To understand this, we need to go to the basics. We are familiar with a traditional form of development called monolith architecture. In monolith architecture, developers simply develop an application on a single code base. This is very easy to understand. Think about the days you started your programming journey. Those days you had no familiarity with architecture and you developed your application in a single code base. This type of development is kind of a monolithic architecture. Might be if you developed that application a bit further and if you had given that kind of application to some of the clients. So this is just an example for you to understand. Imagine that you had developed such an application and you had given that to a client. The good thing is that your application worked effectively and it becomes popular. So you need someone else to help you with your application, and one of your friend might be an expert in these different kinds of architectures. So naturally, to evolve your application further, your friend might have architected your application a bit further. So he might be improved it further by splitting your application into different tiers, or we can call this in programming as layered architecture. Back in 2006, when I started developing application, this kind of architecture, like the layered or tiered architecture, was so popular. Every application we open, whether it's a .NET application, Windows application, or an ASP.NET application, we can see 3 different layers there. One will be the presentation layer, which is responsible for presenting the application. Second one is like the business layer, where the associated business logic is there, associated where the different business logics are there, and then the database layer, which is responsible for connecting to different database services and all. So if you ask then some of those who are developing such an architecture, they would be saying that this kind of splitting of applications into different layers help in maintaining the application, as well as if you want to change something. Say for example, if you want to change the database layer, they can easily do that from the database layer itself without affecting the other layer. So this is fine. So this is a kind of a splitting up of different splitting up of application into different tiers or layers, and there will be usually 2 to 3 layers ideally, and some of the application have a 4th layer as well. One of the common thing that you can observe in this type of layered architecture is this splitting is based on technology stack. So if you look into this, the presentation layer will ideally be some kind of JavaScript related libraries, and the business layer will be some kind of business layer where someone who have a familiarity with C# will be working in, and a team will be working on that layer. And coming to the database layer, someone who might be a database expert will be working in that layer. So this is like a splitting up of an application into distinct layers based on technology. So that's the key important feature of a layered architecture, where the slicing is based on a technology stack. However, it is still a monolith because you will be deploying that together. When it went further through the use of different mappings, we can split the different layers independently, and each layer can be deployed independently into a different server. Then that deployment will be happening independently. So that would be fine. But still, if you want to change something on a front end side or to add a new feature to your application, the challenge with this kind of layered architecture is that you need to change that in 3 different areas. That's the problem also when React team came up with an React architecture. They mentioned like the MVC is fine, but if you want to change something or a new feature, or if you want to remove a feature, you need to change that in 3 distinct areas. So instead of focusing on one area, you need to focus on 3 different areas. So that was a challenge with this layered architecture. So it's basically a bit further than a monolith, but still it's a kind of a monolith where independent deployability was still a problem there. So there is a tight coupling exists there. We feel like there is reduced coupling, but in reality there is more coupling. Especially when, as you can notice, when you need to make some change, you need to change 3 different areas. So layered or tiered approach based on technology help to an extent some form of development and also for maintaining the application. But there was more scope for development, and thus evolved other form of architectures like the modular monolith. And before we move further into understanding the modular monolith as well as the microservices, we need to think about this layered architecture a bit more. Actually, this layered architecture is an evolvement of the famous Convoy's law. If you search the Convoy's law, you will get the definition. So this is an Convoy's law says that organization which design systems are constrained to produce designs which are copies of the communication structures of these organization. So there will be some form of communication structure or organizational structure inside these organization, and this layering architecture based on this technology stack is a direct representation of that. So we can think like this. This layered architecture is a kind of an implementation of Convoy's law, and this helped organization to a great extent, especially to group related technology people like DB teams, .NET teams, and so on. So like I said earlier, the database layer can be developed and maintained by the DB teams. So it's not bad. It's a kind of an optimized system based on technology and skill. However, still, if you observe it clearly, you can view that it's still a silo form of development, because software development evolved further from there, and it demands a group of multi-skilled people, or we can say like poly-skilled people, which are a requirement for every team. So instead of having a set of database developers working in on remote areas as a silo, there should be a team which have multi-skilled people, preferably a database developer, maybe a C# developer, maybe a front-end developer, and so on. So such a combination of a poly-skilled team people is what the modern software engineering required, and organization also required such kind of approach. And so this Convoy's law implementation based on technology stack didn't serve that purpose, and so the monolith and the layered architecture was not a good fit, and it didn't scale up that level as we expect. So a further evolution happened from there, and that's the concept of modular monolith. So in modular monolith, the code inside the process, that a single process is divided into different modules like module A, module B, and so on. And you can see that for many organizations, not all, for some type of organization, the modular monolith can be an excellent choice. If the module boundaries are well defined, it allows a high degree of parallel work, but at the same time, it avoids the challenges of a more distributed microservice architecture by having a simpler deployment topology. You can understand about this modular monolith and its some of the benefits by Google the term Shopify space modular monolith. So there is an article which is presented by Shopify, which is an organization, and they say that they have used this technique as an alternative to microservice decomposition. And they mentioned that it seems to work really well for that company. The one reason why they are mentioning is like we just discussed about the monolith, where everything related to the application is tied inside a single code base. So that is monolith. And we also going to discuss, not discuss that, we also going to discuss about microservices, where an application is divided into distinct modular services which are independently deployable. So in between, there is a architecture called modular monolith, where a single monolith and its process is divided into different modules. So the advantage here Shopify mentions is that it allows them to maintain the entire code base in one place, and they can deploy that to a single place. So they are saying that deploying the application, the Shopify application to a single place has many advantages. One of the benefit they are mentioning is like they need to maintain only one repository, and they can easily search and find all functionality in one folder. So in addition to that, because of this kind of architecture, Shopify only have to maintain one test and deployment pipeline, and thus they can avoid a lot of overhead, because according to them the pipelines can be expensive to create, customize and maintain. So if code is deployed in one application and the data can live all in a single shared database, a simple database query can help to retrieve it. And also the network traffic is very fast in modular monolith, because everything is there in a single place, deployed to a single place. So there is no question of network latency and all happen as in case of microservices. And also the avoiding the network and the communication over APIs. So they don't have to bother about the API version management and backward compatibility and all. And also as well as the delay in the network call. So these are some of the benefits which Shopify mentioning in their article. If you are interested to read the exact article, I suggest you to search for Shopify, SHOPIFY space modular monolith, where that article itself give you a clear and good picture about this modular monolith. So I recommend you to go through that. By going through that article, you will get an idea about all that I discussed now. That is about the monolith, modular monolith, as some of the advantages, as well as you will get a little bit familiarity about microservices as well. I will explain more about microservices soon, but I suggest you to bookmark that link and have a look at it, so it's give a clear picture. And another thing is like, because Shopify mentioned that modular monolith is best for them, it doesn't mean that is the ideal choice. For different organization, different form of architecture is what required. It's based on the requirement of the application, how much scalability we want, and what are the different changes that we expect in our application. Based on that, we need to ascertain. So a lot of factors are there. We will discuss all that soon. So that you should keep in mind while we discussing about microservices or its predecessors like this modular monolith or monolith. Don't have a field like this will be the one that I should choose. Nowadays, we can see that lot of developers who are new to information technology, when they are joining some project, they prefer something like Docker or something, and naturally the development leads who want to take advantage of the newest things, they prefer some kind of microservice form of development. But as you can see in the famous book Building Microservices by Sam Newman, if you go through that book, you can understand that even though he recommends microservices and lot of its advantages, still microservices is not a good fit for every kind of application. The one reason for that is that while microservices gives you independent deployability, the less coupling and parallel development and lot of other benefits, still it comes at the cost of many factors. Like one thing is like you need to have an infrastructure to maintain the different microservices. You need to be aware of the network delays that can happen between your microservice code, and you need to mitigate all those things. And microservices should be developed in such a fair way that it should be resilient. If one service fails, it should recover immediately once it's back. And all the other services should understand that the service has failed, and the next time when it is back, it should recover from there. So this way, there will be less coupling between services, and each services must be resilient, and there must be proper service boundary defined to split the application into different modules. So if you understand microservices simply, you can search about search in Google about microservice architecture, and you will get a lot of definitions. One of the definition I will read. So it is like this: a microservice service is an independently deployable component of bounded scope that support interoperability through message-based communication. Microservice architecture is a style of engineering highly automated, evolvable software systems made up of capability-aligned microservices. So this definition looks like a bit complex. If you extract some of the terms from there, one of the main unique feature of microservice is the independent deployability. Like as in the case of a monolith, we have a single application in a single code base. So here, based on business domain, that is the key factor you should consider for splitting up a microservice. Remember, it's not based on technology stack. We talked about layered architecture where we split the application based on technology stack. So that is the entire and layered architecture. So that is not the case with the microservices. In microservices, we split the application based on the business domain. So domain-driven design is a basic helpful pattern for this kind of splitting. So once you understand a proper domain, and once you split and once you define a service boundary, you can convert that boundary into a microservice, and your application will be having a lot of such microservices which works independently and will be communicating through some mechanism, through some API, and then together with that, it all works together in isolation for in such a way that it can withstand some of the user demands and all. So there are different definitions out there. And one thing you can consider easily for understanding microservices is independent deployability. So if you are developing an application and you feel that it should be developed as a microservice one, then independent deployability is an indispensable component of that characteristics of that microservice. And as a development team, you should be able to deploy specific part of your application. We call that as modules without affecting the other parts. So that modules should have scalability. Scalability means that each module should have the necessary scalability to meet user demands. And also it must be resilient so that in case if it fails, it should automatically recover once it backs. To make this all happen, as a developer, you have to develop the application in a different way as opposed to monolithic or modular monolith. The splitting is very important here. The split of application into different modules based on the business domain. That is the key factor there. We will discuss soon how we can split our application or how we can convert our existing monolithic application to such associated microservices. Now, before we think about whether to develop an application in microservice architecture or not, based on the definitions we understand, we can relate that to an example of a general world example that we can see. We all use applications like Amazon shopping website as well as the audio service like Spotify. If you look into this kind of application, you can see that there are different domains out there. Say for example, in the case of Amazon, you can see that there are different domains like shopping, cart, then the payments, warehouse, rewards, and so on. And you can also see some of the other things like recommendation area and all. So these are all isolated components or modules and which are working independently, and the developers of Amazon shopping had made it in such a fashion that each component of that particular application, or we can call that as a domain, so that part will be handled by a microservice, and together all these different services work in coordination without depending on each other, and that way they will cater the demands of the user. To take an example, if you are using Amazon website, sometimes when you add the different items in cart and in your wish list, and once you began to make a payment, think that if the bank API is down, then that payment service won't work as we think. But it doesn't affect the other areas of the website like the shopping or the recommendation service or anything. So this is the characteristics of a microservice architecture, where it can work independently without depending on depending on other service. Even though we see Amazon as a single website, we should understand that that's a combination of different modular services which are working in parallel without having any relation, and that way they are catering the needs of the users. So there one should understand that even though it doesn't have a direct relation, still it must be communicating with other service through the API and all. So that is why once you shop something and when you click the buy button, it will be triggering some of the different services behind the scene, and each service will be working in isolation. So if the payment service failed currently, it will do a retry after some time, but that's the responsibility of the payment service. And if an architecture can be evolved like this for your application as well, then the advantage that such a kind of microservice architecture would bring to you as a developer and for your team, as well as for the application as a whole, is like this kind concept of modularity. So each module can be deployed independently. It can be scaled independently. Sometimes imagine if you need, if more users are visiting the website through during a sales day or some other important day, then you can scale a particular area like the shopping service or the card service to further based on the user demands and without affecting the other areas. So that's the key here: independent scalability and independent recovery from failure. These all are some of the characteristics. And also for the development team, because here we are slicing the application based on business domain, and an entire A to Z related to that domain can be served by a single team. So that reduces dependency. For example, this payment services can be handled by a team of, say, example 5 to 10 developers who might be expert in developing payment related services, and they can focus on their part without depending on other services. And similarly, the recommendation service developers who might be an expert in artificial intelligence or machine learning, where they can leverage some of those concepts to here and they can develop their particular area. So these are the advantages that it brings to developer as well as for the application as a whole. Now think about that early layered architecture we just thought about, or you can think about that modular monolith or some monolith architecture where you all developers will be working together, and if someone make a change in one area, it will affect the other person. So these are things you should you can understand how it easily facilitates the development. And also in the case of a website like Spotify, where it's splitted into different modules, and one of the user visible module like the front end will be handled by a UI team who is expert in front end technologies like React. So they can use their knowledge to bring out the best beautiful user interface as they can, while the behind the scene things like the payment and other related areas can be handled by a separate team. So this means less coordination is required between teams, and that's one of the advantages that this microservice bring to a developer. And in addition to that, scalability, reliability and other things are also another considerations. Think about the scalability concept. Think that you deployed an entire monolith to a server, and think that one particular area got overused and it consumes a lot of the user resources, a lot of the machine resources. Because everything is deployed in a single machine, that means it affects the other components as well. So if one process consumes a lot of the server resources, and if other components are also deployed in that same machine, as in the case of a monolith or as in the case of a modular monolith, that means it affects the application at all. That won't happen in the case of microservices. So this comes at a cost as well. So that is why Sam Newman, who is an expert in the field of microservices, mentioned this in his book. So even though these are all some of the benefits of microservices, still building an application using a microservice architecture is really a challenge, especially because it's a distributed kind of services where each services have no direct relation with other service. So we need a logging mechanism as a prerequisite there to understand what is happening behind the scene. Unless we have a proper logging mechanism to understand what is happening behind the scene, exist in advance. It's not an afterthought. It should be there before we start developing the microservice architecture. So without a proper logging in place, it will be difficult to trace what is happening in microservice architecture, especially when we will discuss about the communication that is happening between these microservices. We will encounter a term called asynchronous communication, where each microservice communicate with other microservice not directly but through a queue or something. The reason why we put a queue in between is that if one microservice fails, still that message will be there in the queue, and when that microservice recovers, it can get that message from the queue and it can do a processing. So that won't happen if one microservice directly contacts another, and if that microservice fails, it will fail this microservice as well. So to avoid that, in the areas we see that we should establish an asynchronous communication, we use something like a queue or a topic. So coming to all these, the idea is that asynchronous form of communication can happen, and that brings a challenge for the developers or the operations team as to identify what is happening behind the scenes. So a proper aggregation of the different logs or a coordinated logs aggregation mechanism should be in place before attempting to fully convert an existing application to microservices. Even if one develop an microservice, still an logging mechanism as a prerequisite will be very helpful. Otherwise, it will be very difficult to understand what is happening behind the scene. So we'll discuss more about that logging mechanism and all a bit later. Next, we can think about how we can define service boundaries and how we can split an application into different modules. If you read through the book of Sam Newman, which is Building Microservices, and that's available from O'Reilly publication, you can see that Sam Newman suggests to approach this microservices development incrementally. This means that if you have a monolith application, and if you fully analyze the application, and if you feel that you need to convert that into a microservice architecture, you need to do that incrementally. So there are different patterns he mentioned in his book, and one of the pattern is called a strangler pattern, where you extract a certain part of your application where you feel that it can be converted to microservices, and then you will redirect the calls related to that particular area to the new service. So this way you will be incrementally extracting each part of the monolith until finally you fully switch over to the new services. So that is one approach called the strangler pattern, strangler fig pattern. So if you search strangler fig pattern, you can understand about that. So that is kind of an incremental approach which one can follow to convert an existing application to microservices. And Sam Newman's another one important mentioning in that book is like, even though many were thinking like, because of the advent of Docker, serverless and different cloud technologies out there, still the de facto standard for starting any kind of application, especially if you are not familiar with an architecture, is still the monolith, because the monolith has the scope to convert that to a microservice later. So if you are not familiar with what you want to go ahead with a microservice, then starting off with a monolith can really help. And also another important point he mentioned is like, before understanding fully about a business domain, if you start developing microservice architecture, you will be baffled. So to effectively define the service boundary and to split the application into different modules, it needs some time to understand the different entirety of the application and the different business domain and all. Only then we will be able to split out and extract that into a service. The main characteristics of the microservice modules is that high cohesion, means that if you look into a service, say for example a payment service, it will be cohesive. It means that all the different codes that are related to payment will be embedded in that service itself. So it's kind of an encapsulation, and that will be transparent to other services. So other services will be contacting this payment service only through an API, and everything about what is happening inside that payment and everything is hidden within the payment service itself. So that way the proper grouping of, we can call that as cohesive kind of an approach. Cohesive is a characteristics that is must for an microservice module. Otherwise, if you develop a module and some of its functionality split is there in another service, it will be a problem. So everything that you feel to group as a module, or that to be grouped inside a service boundary, you need to group that effectively. So that grouping can be possible only if you understand properly about the business domain. So that's the reason why, without understanding about the business domain, if you convert a monolith to a microservice, and for new application in the earlier stages of development, without fully knowing what all are the requirements that can happen, so it will be really a challenge. Because if once you develop an module, later you are understanding that it should not be working in this way and some other way it should work, and you need to group other areas as well. So it will be a real challenge. So understanding properly about the different business domain that are related to that application is a key challenge in developing whether a new microservice or as well as converting the existing microservices. And to convert the existing monoliths to microservices, first we need to think whether that kind of conversion is required or not. So Sam has said in the book, like if there is a trivial application for a POC or some purpose, and which is just for a demonstration, attempting that to be a microservice architecture would be an overkill. And if there are developers within 5 to 10 for an application, then also converting that to a microservice didn't help. But if you feel that your application has a scope for further development, then microservice architecture can help. So proper analysis is one thing that you need to be aware of. You can read about that more details in that book. So these are some of the key points which I mentioned. Next thing is like, how can we split the application? So if you want to split the application, there are different ways to do that. So one of the initial approach where I am going to explain here is a process called seed process. So the idea of seed process is like, we will be identifying the different APIs that are related to an application. So why API means that in microservice, every module will be contacting to other services through an API. So we think an application from an API perspective or application programming interface perspective. So that's the main idea of this seed process. So seed is a kind of a process. You can search that in the in the Google, and it will give a good picture about the seed process at all. So the step is a bit different. Like we first analyze the application and we think about the application in terms of APIs. And once that API is confirmed, APIs are properly defined, then we should think that there is an associated related microservice module that lies behind that API. So there we define properly the microservices. So that's one concept. So again I am telling that process that is called SEED, SEEED. And the process is like, first I will give a quick overview about that process. First it is like you identify the actors that are involved in interactions within your application. So they are called the actors. And based on their actions, what the actors do, we identify or derive a higher level actions. Okay, once you derive a high level actions, then we will be defining an API based on that. So if you take the example of a modular shopping website, and if you think in terms of actors, we can see that there are different customers out there and they will be contacting to the system. So we will form some of the higher level actions like the payment, shopping, the cart, adding to cart, and also once you form a set of derive a high level actions, we can define an API behind that, and then behind that we can create an associated modular service. So that's the concept of SEED process. And SEED process can help you to define some of these things, and the different APIs then that way can communicate with each other, and then they can together form an microservice architecture application. There is another way which is called the event storming. Event storming is also a method you can search in Google, and which can be helpful to identify the service boundaries. So this is considered just like an exercise like sprint retrospective, where everyone who are interested in the application sits together. So there are different kinds of event storming process. If you search in Google, you can see like a main event storming process as well as a lightweight event storming process. So you can, it is recommended to use the lightweight event storming as it helps to discover some of the more aggregates in your subdomain and with less complexity. So to participate in this kind of event storming and to identify the different service boundaries, everyone who is interested in our application should sit together, and the goal of the exercise is to identify the events. So that's the first stage. So there is no coordination in this first stage. We will tell different participants like please identify as many events as you can. So if it's a shopping website, participants will be identifying the different events like payments, the shopping, then the recommendation, and maximum events will be that. So this phase usually take around 30 minutes to an hour depending on the size of the problem and the number of participants. And all the different events that we captured from different participants are added to a sticky notes, and it says that there should be a minimum of 100 events there for an application. So it's not a fixed number, it's like kind of a varying number. For an enterprise application, it's recommended like around 100 event sticky notes generated, but it varies according to your application. So this is the first stage. We will capture from all the participants the different events that are related to our application. So if it's a new application, we will be thinking about that application and the possibility of the application, and then generating the event. if you are converting a monolith to a microservice architecture, then we will be defining the events based on the existing application. For the existing application, as we already have an application in place, it will be easy to identify the events. But in the case of other or a new application, the participants needs to think about and visualize how the application will be like, and then they will be creating the events. So next, the second phase of the exercise of event storming, where there is a facilitator who help to arrange these events into a more coherent timeline, and also they identify the duplicates. As we can see in the first phase, we won't tell the participants like you don't create an event which other created. So the only goal in the first session is to capture as many events as we can. So there might be duplicates, and in the second phase, a facilitator helps to arrange these events into a more coherent timeline. Then they will create a storyline walking through the events in an order that creates something like a user journey. And naturally, there arise some questions like a user, when we define a user story or a storyline based on these events, naturally questions or confusion can happen, but we kept it aside. We won't solve in this phase. I'm explaining each stage one by one. So this phase can also take up to around 1 hour depending on the context. So next is the third stage, which is called as reverse narrative. So here we walk the timeline or the storyline backwards from end to the start, and we identify the main command that caused the event. So it's like, for example, if you in the case of a shopping site, if you submit the payment, then we identify the set of different main events that cause that particular storyline or the timeline is this payment submission or the payment authorization, and based on that a set of different events happen, like the payment processing happen, then the bank return information happen, and then the payment success failed message happen. So these all different events are captured based on that, but we will identify the basic command that actually caused this particular event. And you need to aware that a lot of commands will have one-to-one relationship with the event. So there will be a lot of confusions that can happen at this stage, but we don't consider all that. We will just notify that. So we identify that a simple payment submission command will create a lot of related events like mail sending and all, but we just capture as it is. Then in the next phase, we acknowledge the commands that do not produce events directly. So there are a special type of domain entities which accept commands and produce events, and these are called aggregates. So what we do in this phase is to rearrange our commands and events, breaking the timeline, and based on aggregates we group it together. So for example, there is a if you consider about a shopping website, after the shopping is over there will be a survey. So based on that survey there will be a set of events like leave a rating, rate my experience, then review of website, and all the associated things. So we will be grouping that like that. So this phase can take up to around 50 to 25 minutes. So once we are done everything, we will be identify like our event storming final outcome has a set of time limits of events, or we can see a cluster of events and commands grouped around associate aggregates. So these are the different phases that are there in the event storming, which helps to identify the boundaries. So I will again explain about the different boundaries quickly. To understand a bit more about these different aggregates, you can check up the book like there is one book that is published by O'Reilly, which is called Microservices Up and Running. So if you look into that book, you will get a detailed picture about how to define a service boundary using event storming. So a detailed description is presented in that books, and also it gives a good picture about that seed event and all. So I suggest you to go through that book to get a full understanding about the different event storming practices that you can work on. So there are totally 5 phases. So first phase is like 30 minutes. It's to identify as many events as we can. And second phase is roughly took around 45 minutes. It's to identify the storyline. And on the third phase, we will create a reverse narrative and we will identify the main command that caused these events. Then on the fourth, we will identify the bounded context or the aggregates. And finally, in the phase 5, we do an analysis based on all this, and we identify the service boundaries. So this event storming is believed to help informing the service boundary properly. So that's one of the advantage of having this event storming exercise. So, and together with that seed, it will help you accurately to identify the service boundaries. There are other ways also you can take or consider. Like these are 2 ways which I explained. Another way is like you can check out your monolith application or an application which you plan to do, and think about whether there is a part of your application which has the possibility to change. So if you expect a change in one particular area of your application, you can extract it into a different service. And based on that, a team can work on that and they can develop that service independently without affecting any of the other service. If you remember, I told earlier, one of the main unique distinct feature of a microservice architecture is independent deployability. So that team who are working on that particular service should have the freedom or liberty to work on that module, develop it, test it, deploy it, and without affecting any other components of the same application, they should be able to deploy it. So based on that, if you analyze your application properly, and if you feel that one area might need some change which can help your business, then extracting that to a microservice is another way instead of doing with this event storming. So event storming and seed process are different techniques which are presented out there. These are tools which can help. So these are tools which can help, but these are not mandatory to have in defining microservice architecture. And another thing you can think about is like, if you feel a bottleneck in particular area of an application which needs some scalability, then you can extract that to a modular service. So this is the approach which we can use to convert existing existing monolith to microservices, where we identify the areas that have the possibility to change as well as the possibility to scale up, then we will extract it and convert into a microservice, and we can route the traffic to that microservice using based on that triangular pattern. And finally, Sam mentioned in his book, like there exist many applications which have a set of monolith as well as microservices, and that can also help. Because we are thinking about microservices architecture, it's not mandatory that we should be converting every part of the application to microservices. So that may not be feasible, because having a microservice architecture in place, and it's to keep the infrastructure properly, different mechanisms like a Kubernetes and all are required. So it may not be feasible for all projects, and based on more you convert a monolith to a microservice, the more cost or for maintaining and more complexity will arise. So this is one area of complexity where the infrastructure complexity, like how to maintain that application, maintain that modular microservice is comes to you. Second one is like if something happens inside that microservice, you need an accomplishable logging mechanism also in place, which can help to coordinate the different events out there. So when I gone through an article, I could see like there's a dashboard. They have a set of microservices, and they have a dashboard where it indicates exactly what these different microservices are doing and where an error happened. So based on a coordination factor, they can able to identify at exactly what point that failure happened. So that was possible because they had a log aggregation mechanism in place from these different microservices. That's the reason why Sam Newman has mentioned like we need a log aggregation as a prerequisite before we attempting to move the microservices, because the more you move your services to microservices, the more the challenge will be. So that's the area. Now let's talk about the communication that can happen between these microservices. That is another area where we can discuss. Usually, the preferred way for communication between these microservices is like through the case of a RESTful API, and that's over an HTTP. But there are some new advancements came out, like the gRPC. That's a remote procedure call based technology, where it's a kind of an abstraction which is developed by Google, where the call is rerouted, where the call is routed through the HTTP2 protocol, and that will be transparent to that will not be visible to the caller. So you can have the different NuGet packages for .NET for including gRPC. I think in the newer versions of .NET Core it's actually there. You can call the remote procedure using gRPC services, and it transfers the call based on HTTP to protocol using binary formats such as protobuf. Also, GraphQL interfaces are also there, which can help to communicate between the microservices. But the default or the normal way for interacting with a microservice, whether that microservice is interacting with each other or through other different ways, is through the RESTful API, and it's based on HTTP, and it should be over a secured connection like the SSL or TLS. So that's related to synchronous pattern of communication between microservices. But on the other side, we can have asynchronous communication as well, like the publish subscribe type of interactions. So in this interaction pattern, the upstream can generate events and the downstream services can subscribe to that events and they can do the processing. So this means that the upstream services or the event generators can just trigger that event and they can forget other things, and those other interested services or the downstream services can subscribe to it and they can do the work as they like. So this kind of publish subscribe patterns are very complex to implement and debug, but the advantage that bring to the microservices is like they offer a superior level of resiliency, fault tolerance, scalability and flexibility. Nowadays, the cloud providers like AWS and Azure provides a lot of different services out there. Example is like the SNS service, simple notification service, and SQS service, the queue service, where you can publish the event and the associate subscriber can subscribe to that. Similarly, the Azure service bus, you can send to a queue and the interested parties can queue that item, or also you can follow an asynchronous pattern like publish subscribe, where an upstream service microservice will publish the event to a topic and then the interested parties can subscribe to there. So there is less coupling happens in this case as opposed to a synchronous communication. In the case of a synchronous communication, the two microservices are contacting through some form of an API like the HTTP or through some gRPC codes, but that communication is actually asynchronous. If one service were not able to reply to that event, the call fails. So, but synchronous is helpful in some situations, like for example, if you want to query something and want to show to user, then synchronous communication will be effective. While some of other kind of events like payment done or something, then the shopping website can insert that information to a queue or a topic and the rest of the services can be read from the queue or topic and can proceed accordingly. So it depends on what we want to achieve. We can leverage whether we want a synchronous communication between the different services or we need an asynchronous communication between the services. So one thing I would like to mention here is like gRPC is good. So if you look into the book by Sam Newman, he's mentioned like gRPC is good and it offers some of the possibilities of HTTP2 and all. But some of the things are abstract under the some of the things are hide from the user under the gRPC mechanism, so they won't get an actual picture of what is happening behind the scene. So in the case of an HTTP call, we get an understanding like, okay, the service is calling that HTTP and getting a return. But when we abstract something using the gRPC, an underlying call is happening there. So coming to the communication, as we discussed, there are different ways like the HTTP REST API, then the remote procedure calls like the SOAP or the gRPC. So this gRPC, it looks like the remote, these are frameworks allows for local method calls to be invoked on a remote process. Then the REST API is the default standard we can use for communicating between the microservices. Then there is a protocol called GraphQL, which is a relatively new protocol that allows the consumers to define custom queries that can fetch information from multiple downstream microservices, and they can filter the results to return only what is needed. Then there is another way of asynchronous communication. These REST API, GraphQL and RPC are all synchronous communication, whereas there is an asynchronous communication called the message brokers that allows to communication via queue or topics. Some of the examples of this message brokers that allows asynchronous communications are this Amazon Web Services SQS service, Symbol Queue service, and also in the case of Microsoft Azure, there's a service bus which allows you to define queues as well as the publish, subscribe, pattern, topics and queues. So these are message brokers that acts like a middleware for asynchronous communication. One of the main thing you remember while implementing the gRPC clients, gRPC mechanisms as a communication way in between your microservices, the core idea of this gRPC like mechanism is to abstract the complexity of a remote call. So they are actually hiding the network calls, even though they are using the HTTP2 and some form of serialization and all, but still a hiding is happening there. So you should think about that the network is actually unreliable. So one of the common problem that everyone think or everyone unaware while developing microservices architecture is that they will think like these services can communicate with each other, but the reality is like networks are not reliable. They can fail. So you need to think that even though you are using gRPC, still it's actually a network implementation is happening behind the scene, and don't expect that gRPC will get a proper return. So you need to aware about the network issues and all when implementing. And also it's actually some of the times it actually force some of the logic on client side. So if there is a method on the server side and if your client don't wants to use that, still they need to generate that, and they can either ignore that new field, but still they need to regenerate that, and whenever there is a change happening they need to regenerate it again on the client side. Whereas in the case of the HTTP API, you can simply switch on that. But still, if you look into the Sam Newman's book on building microservices, you can see that he mentioned some of the different advantages that this RPC, remote procedure call, brings to microservices. And he mentioned like he's interested in knowing more about this, and at places we can use it, but one should be careful. Otherwise REST or GraphQL will be a good fit for that. And for clients like mobile devices, it is recommended to use the GraphQL. Actually, GraphQL is a call aggregation and filtering mechanism. So in the context of a microservice architecture, it would be used to aggregate calls over multiple downstream microservices. But it not replace a microservice to microservice communication. So there is another pattern also there called the backend for frontend pattern, or the BFF pattern, where it aggregates the different API returns and shows that to something like a dashboard or something. So that part, that is also useful when you want to aggregate some of the informations from different APIs from the microservices, and you want to show that to a common dashboard. Then this backend for front-end pattern will be useful. So different communication mechanism exist out there to communicate between these different microservices, like the REST API, which is the main one which majority of the microservice architectures are using. And also you can leverage this GraphQL for aggregation or the BFF pattern. Also, in case if you are feeling okay to use gRPC, you can use that as well. But it's like some kind of technology things are embedded into that client where it is using that gRPC, like the gRPC or SOAP, where the WSDL, you need to generate a lot of code on the client side. There are advantages, but still there are some coupling happening there as well. So we need to think about that and carefully use this mechanism when it comes to microservices. And the next thing that I like to talk about here is like the concept of database. When we think about microservices, usually there is a different opinion among the use of databases. In the earlier understanding about microservices, I have understood that many were telling about one can share the database among microservices, but actually that's not recommended by Sam Newman or any experts in this field. So this shared database for microservices is an anti-pattern which should be avoided at all cost. Ideally, a microservice architecture should have an individual database for each service. If you are sharing a micro database and using between microservices, then that would be a problem. It brings you to a kind of an architecture called the distributed monolith, where you will get the complexity of a monolith and all the problems of a monolith plus the problems of a distributed computing. Because when you combine, when you have different modular services which are tied to a common database, actually it's kind of a distributed monolith where it has the challenges from two different areas, like the monolith as well as from the challenges of monolith as well as the challenges that are associated with the distributed computing. So it brings a lot of problem. So experts are suggesting to avoid at all cost. So instead of that, you can have a separate database for each modular service. So that creates a lot of other issues as well, especially when you think about the transactions. So if you think about the database transaction or if you are familiar with the database transaction, you can understand that in the case of an SQL-like database, if we have a set of transactions there, we can either fully complete the transaction or either we can roll back. So this won't happen in case of the microservice. So there we need to do something else. So one way is to use a pattern called Saga. So Saga means it's a pattern where we will be either completing the entire workflow or we will be reverting it back. So it's just like take a case of an example where we are doing an order fulfillment and there are certain events that should happen as part of that, and in case if anything failed, we will entirely roll back. So that is called the Saga pattern. You can learn more about that in a different episode which I planning later, or you can check out the that Sam Newman's book where he mentioned in the fifth chapter, where implementing Microsoft, not fifth chapter, the sixth chapter, where in the implementing the workflow, he is mentioning about implementing the Saga. So if you look at that, you get an idea about how to implement the Saga to compensate the transaction of a SQL database. So there he mentioned about two kinds of sagas, like the orchestrated saga as well as the choreographed saga. So orchestrated saga, in orchestrated saga they use a central coordinator, or we call that as an orchestrator, to define the order of execution and to trigger any required compensation action. So it's like a kind of a command and control approach. The orchestrator controls what will happen in the entire workflow, and it gets a good level of visibility of what is happening. And in case if anything fails, say for example, in the case of an order fulfillment process, if something fails, then it will trigger a compensating action. So that is called the choreographed saga. So please check out that book and you will get a good understanding about the different sagas. So this is a must for every microservice architecture developer. Then there are other ways as well, like using a data lake. For example, if you have a because in the case, these are problems associated with database, because in the case of microservice architecture, we are having a set of different databases for each different modular service, and sometimes we need to aggregate the data from all the different areas. So if you want to show a read-only data, then there is an approach called the data lake approach, where you can reference all the data from different modular services to a data lake, and you can create a query from that data lake. So that is another approach, and it works well for the reading data. But in the case of transactions, like if there is a series of flow, like in the case of an Amazon, when we do some payment, a series of flow is actually happening, and in case if any flow fails, then we need to revert back. So because here in the microservice architecture, it is happening among different modules, it may not be easy like a simple database transaction rollback. So here we need to use an approach like a saga. So sagas are of two types, as I described, like the choreographed saga as well as the orchestrated saga. So you can look into that and understand more about those things. So that will be helpful for you. And main thing you should keep in mind that you should avoid a shared database at all cost, because that will bring another kind of non-recommended architecture known as distributed monolith, which you should avoid at all cost. You can have, the general recommendation is like you can have a monolith. You can sometimes have modular monolith like the Shopify do, but you should avoid the distributed monolith at all cost. So distributed monolith is what happening when you use something like a shared database for microservices. So I think I covered some of the time is going above 1 hour. So plan to cover other advanced or it's not advanced topic, but some of the related area topics like the saga patterns in more detail, and also some of the build and pipeline consideration, because we just talked about the microservice development. As a basic understanding, you can have a build and release pipeline, which you can set using the different DevOps mechanism. Some of the popular DevOps mechanism are Azure DevOps, GitLabs, then many are there. So you can, based on your organization requirement, then you can set the different build and deployment pipeline, the key thing to remember is that independent deployability should be there when defining the build and release pipelines. And also the workflow of the microservice architecture goes like this. You ideally develop a microservice in your local development environment. You check in the code once you've done the local development to a source control, which in fact trigger a pipeline. And once that build pipeline has been triggered, a set of tests will be running there. So first, initially there will be a compile test which is very fast, and then there will be a set of slow test which usually occurs in the CI environment. And then then there can be different environments like the QA, production and all, and associated different approval areas are there, and based on that will be deployed to the production. So that depends upon how we configure these things. So ideally you can have a copy of the environment in your local developer laptop by installing the Docker container. So most probably you will be developing applications using the Docker form of development, and then you can install the Docker locally and then you can run it. Inside the Visual Studio there will be provision. So if you are using a .NET Core as a platform for developing microservice modules, then you can run it from inside the Visual Studio. And if you install the Docker service, it will be automatically, you can have the option to run it inside the Docker container as well from inside the developer laptop. From there you can check into the source code, and then it will be deployed from the build and deployment pipelines to different environments like CA, QA and production. So each environment varies. So some of the main things you should consider while configuring the deployment is like each microservice should be running in an isolated fashion so that they have their own computing resources and execution, and one execution does not impact the other microservices. So containers will be a good fit for that, because each microservice can run in its own container, and even if there is something problem happens inside that container, it will be crashed and another container can be created, provided if you have mechanisms like Kubernetes in place. Then infrastructure as a code kind of deployment is the one you should consider, because that will help you to easily automate all the different tasks, as well as you can store the entire infrastructure inside the source control so that it will help you to create the environments easily. Then these are some of the main things you should consider. Then you can have you can deploy the container, deploy the microservices in different areas. So you can deploy that inside a physical machine, a virtual machine, or inside a container. So container is the preferred way because that offers a lower cost and faster provisioning. But while if you install inside a virtual machine, the cost will be much higher. But you can install it. There is a way, but mostly for microservice architecture and its deployment, containers would be a preferred choice. And most of the time, organization take advantage of services like Azure Kubernetes services or Amazon Kubernetes services, where we tell the Kubernetes services that we need a cluster with this much resources and all, and we supply the container images, and rest of that automatically that service will be taken care of. So it's kind of an on-demand service where you define to that service what you want, and rest of things will be taken care of by that container, by that Kubernetes service itself. Also, there is another way of deployment for this microservices, which is nowadays getting popular, which is called the serverless or function as a service, where you define these different microservices as a function, and using the services in cloud like the Azure Functions or the AWS Lambda, you can create the different functions as a service, which will ideally be a individual microservice in effect, and that can also work behind the scene. So these are the things I plan to cover in this episode. We will be discussing more about other types of details about this microservice architecture related technologies, like the build, what type of build pipeline you can set, what type of testing you can implement here, and also some of the maintenance part like the logging and aggregation mechanism, all that in a different episode. I hope this is a basic episode, will give you a just an overview picture of what the microservice is all about. So if you are interested in learning more about the microservice architecture, I recommend you to go through the book by Sam Newman, which is called Building Microservices. So second edition is available now. It's from O'Reilly publication. And also there is a excellent book called Microservices Up and Running, which is also from the same O'Reilly publication. You can check out that. So thank you for listening this podcast. I will be coming up with another podcast soon. So do check out my YouTube channel as well as the meetup group. There are different cloud related sessions out there. Thank you once again for listening this podcast. Have a great day ahead.